All right, so lunch break is over, and together with me here on the stage is Markus Müller. Give him a warm applause, warm welcome.
Thank you.
Markus, you've been here in the SDRA all the past years, and I'm very happy that you're attending this year also here. And there's been a lot of updates on GNU Radio. And GNU Radio is known to all of you, I guess. And there's been a book. And once books get written, this is a milestone in every development. And behind me, I have the authors of the book.
Hello.
Jean-Michel on the left and Hervé on the right. Welcome here virtually on our screen. So you see me when I talk to the camera, but I see you when I turn the back to the camera, so that's a little difficult, but nevertheless. So this talk is going to be about this development, about the book, and about the recent developments in GNU Radio in general. And so these three gentlemen know it much more and much better than I do, so I leave them the stage. So Markus, I would like to hand over the microphone to you in that sense. Please go ahead.
So yeah, thank you for having us here. So honestly, it's a pleasure to stand on this stage because my contribution to that book is basically non-existent. I wrote a foreword, but to give a bit of background on why I'm here is I've been with GNU Radio since 2009, 2010, and the one thing that has been direly missing is something to give people to read at their speed and to guide educators into something that they could build a curriculum on, or to guide people on, hey, what kind of system thinking can I get from GNU Radio? And that is the gap that this book actually fills pretty well. So Jean-Michel and Hervé took it upon them to actually write that book. Video, can we? So this is the book. I sadly, and I noticed this morning, left mine on my desk. This is kind of sad, but it's a nice, hefty book. It's rather thick, and it's been out since last fall. So it is really, really on top of current GNU Radio. So how that happened is that Wiley, the publisher, approached GNU Radio as a project, as the project leadership, and they asked, hey, could you write a book? And we looked around and we found Jean-Michel and Hervé that who were actually gracious enough to then actually write that book. So I'm super, super thankful that they did. Because it is something that no one ever gotten around, and that was very foreseeable, a large investment of effort. So that actually leads me to a question there, and that is, well, two professors at French universities are probably not the least busy people in the world. Why did you actually start writing that book? What was the motivation to do that? And was it the fame, or was it the money, or was it something else that made you write this book, Jean-Michel and Hervé?
Yeah, thank you, Markus. So actually, we've been lecturers with Hervé for more than 10 years, teaching radio frequency communications. And we were actually using GNU Radio for a long time, not only because it allows us to introduce some rather complex topics of digital signal processing, but also because it meets our objective of having the students install the software on their own computer and learn from the source code. And so free open source software were obviously meeting these requirements. And for a long time, we've been discussing with Hervé about writing a textbook to help the students learn at their own pace. And so actually when the GNU Radio General Assembly mentioned that there had been a request, we were completely ready, and we had most of the plan and outline ready with Hervé for presenting the book. So that's my perspective. It was something that was long-lasting, and we were just pushed to complete the book when we were asked to. So that was a great opportunity.
Cool.
Well, yeah, on my side, well, I did it mainly for the money, to be honest. No, that's not true, because if you want to know about the money, for authors of such kind of books, it's 2% of the price of the book. So of course it wasn't the money, the motivation. No, in fact, as Jean-Michel said, for me, as a university teacher and also a researcher in communication systems, I've been convinced about the software-defined radio technology, and especially convinced about GNU Radio. We've been doing the promotion of GNU Radio in Europe with Jean-Michel, organizing several conferences called European GNU Radio Days. So it was quite obvious to carry on to promote the software, writing this book. There was also a motivation I had for a long time, and this was because of a discussion with an amateur radio in Friedrichshafen. This was in 2021, when Jean-Michel and me came to SDRA, and this amateur radio colleague, just from Poitiers, he came to me and said, you know, the problem we've got with SDR is that we haven't got the background about digital signal processing. And that's why I decided to, well, I had this in mind when I wrote the book, because there are a lot of different topics related to DSP, and this was just a great opportunity writing this book about these topics. So, well.
Okay. That is interesting, especially that you mentioned European conferences and the breadth of topics in DSP that you can cover, because as a slide I prepared here is something that Jean-Michel showed at 2024's 24th FOSDEM conference in Brussels. And I don't really want to reiterate his talk. So what you see here is that Jean-Michel built something that moves on a rail and allows high resolution radar imagery to be captured with means of a relatively small antenna, which is very impressive if you think about, you know, beam width and stuff. So aside from the very amateur radio, how do I build a communications system? I guess one of the things that you do with DSP is radar, is imaging systems. So I recently rewatched that presentation, and as usual in the Jean-Michel Fried shows, it's a very fun, very engaging, and very dense presentation. So I wasn't sure whether someone who had never done something with SDR would actually understand most of it. So can you go a bit into what the book would give such a reader for, say, designing such a complicated system, or designing a modem for communication things, which seem to be a bit of a different problem, please?
hear
so
you,
what really
Jean-Michel.
attracts me to, yeah.
Okay,
So yeah,
it's okay.
the background for me was that with your SDR, you have access to the IQ stream, and so despite the book being entitled Digital Communication, I really wanted to have a chapter about how you can do beamforming or how you can do analysis of electromagnetic wave properties. And a rather tricky concept such as cross-correlation or running a cross-correlation with the Fourier domain are things that might not be completely obvious. And the beauty of GNU Radio is that you can first try all your algorithm on synthetic signals or on pre-recorded signals. So actually the book sample files are all available on iqengine.org. So you can actually download the file, and even if you don't have access to the signal, you can replay and analyze at home all these signals before actually connecting your real hardware, your B210, your RTL SDR, whatever hardware you have. And that's really one of the highlights of GNU Radio, is that you can actually first test on synthetic data and then on real signals. And so what we try to do here is always to introduce the concept of DSP and then to run them on recorded files and then to actually use a real hardware. And I really want to emphasize, quite often people come and see me and say GNU Radio is a complex software. And I don't believe so. I think what's complex is digital signal processing. Or not complex, but there are things that are not obvious, like the relation between filter transition width and the needed computational power. If you don't understand this relationship, then your flowchart is completely wrong, irrelevant whether you're running it in GNU Radio or something else. And so we wanted to give some DSP background, some low-level background, and then, of course, some digital communication.
Which is probably the cue for Hervé.
Okay. Yeah, I just want, as Jean-Michel said about the files, I wanted to mention a website that can be used by people not having any hardware to test with signals in GNU Radio, and that's IQ Engine. In fact, it's really nice because you've got a lot of people having put a lot of files. They have recorded on different radio systems, and you can get these signals, use them into GNU Radio, and test the different signals with different DSP algorithm. So that's really nice. Another point I wanted to mention, Jean-Michel is a Linux geek for many years, and I wasn't. So I changed completely, getting rid of Windows 6 years ago, and I'm pretty happy about that because, well, GNU Radio, a lot of people think, okay, it's Linux, it's going to be complicated. It's no longer the case today. You can use GNU Radio inside Windows, although I would recommend Linux, but it works pretty well. Yeah. So don't be frightened about that. It's, as Jean-Michel said, it's really a nice software, and it's quite easy to use. In the book, I wanted to go about something I did before using a commercial software called MATLAB and Simulink. I wanted to build a QPSK modem. So it's a digital communication system. It's not simulation. It's something with GNU Radio. You build really systems. You've got the two antennas between the transmitter and the receiver. So you have to take care about important things in the real system, and these important things deal mainly with synchronization. So you've got a lot of algorithm already implemented in GNU Radio. Of course, you have to understand the minimum about how to use them, but you can play with these different algorithms, changing the different parameters, and it works pretty well. So in the book, I wrote a chapter about this QPSK modem working with continuous stream of data and also with packet type communication. And it was really quite interesting. And GNU Radio has got everything. You don't have to be a computer geek to do something really interesting with GNU Radio. And for amateur radio, for the amateur radio community, I think it can be really, really interesting to experiment with GNU Radio. I've got a few examples recent for me. I tested don't know, a lot of people in the room must know about Meshtastic, which is something quite used by the amateur radio community. It uses LoRa, so you can use GNU Radio to for Meshtastic communications using an out-of-free module about LoRa. I just I use it for that, and it was quite handy to understand the technology which was behind the Meshtastic. So just an example for the amateur radio community. But it's so flexible, and that's because it's software-defined radio. You don't have to use all the time your soldering iron to change components and things like that. I'm an electronician, I like that. But the flexibility of software is just something really great.
So that is interesting in the sense that you said it is a big hurdle to tackle the DSP side of things, right? It's not only you need to learn the software, but you need to learn the basics, the math, which we saw today, thanks to Michael, and other things. So, were there any things you've learned while writing that book about GNU Radio, or about the theory that you didn't realize before?
Definitely, and that was actually something we moved to the conclusion. It was the limitations of software-defined radio. And I should emphasize, not of GNU Radio, but software-defined radio. As soon as you start working with digital processors, for example, pi cannot be approximated as a rational fraction. And so you will always have an error, and these errors accumulate. And so we discovered while writing the book, while getting deeper and deeper in each algorithm, some of the limitations. And I had always been repeating to everyone, look, if it's software, it's reproducible, it's reconfigurable, it's flexible. And yet, by getting deep into each algorithm, we actually ended up figuring out some of the limitations. And well, that was actually moved to a conclusion because we didn't want to make the reader believe that there were intrinsic limitations to the software processing because there's so many great things you can do. But there are indeed limitations from the digital processing of software, of radio frequency signals.
Well, something I learned a lot about my limitations concerning software development. And in fact, I had already the knowledge about FPGAs, so about parallel processing and things like that. But going inside the code, well, as an electronician, it wasn't easy for me. But well, it's just a matter of time to handle these things. And to be honest, we discussed about that also with Jean-Michel. Something that's gonna be difficult, I mean, for me in particular, is the new version of GNU Radio 4, because it's another level. I understand a lot of things about the fact that it can be really efficient. The speed is going to be better for a lot of algorithms and things like that. I'm okay with that, but I'm not really a C++ geek, so it's something that's going to be difficult. But in 2 or 3 years, I'll be retired. I will have time to. I expect to catch up on these fields.
So I know very few people that are as busy as retired people. So I wish you the best for that. Like I said, I'm involved with the GNU Radio project. So let me lose a few words. Like GNU Radio 4.0 is the upcoming version. It's in heavy development right now. We are certainly not at a stage where we say, oh, everyone can use that and use it as a drop-in replacement for what GNU Radio is today. There's simply not the block library. And I very much invite everyone to contribute to that by testing it, by building it. But right now we only have like the C++ basics, so none of the nice graphical framework that you know from your GNU Radio Companion where you can click together flow graphs. We have none of the Python bindings. All of these are things that the community needs to come up with. And as a project, we are certainly working on that, and we're actually trying to get grants to fund some of the work where we're not, like as DSP experts, it's not always easy to find someone who's willing to write a good user interface, because most engineers' user interfaces are not very user-friendly, actually. So that is definitely something that I'm just in the same boat as you. I'm not familiar with a lot of concepts yet that we've just implemented. I haven't written any of that. So this is still a very much something that we're working on. But on that note, and knowing both of you are here, I'd like to call out that the people who are doing the GNU Radio 4.0 development are meeting in Lyon, starting on the 16th, I think, of July, for the week. So if anyone is very interested to contribute or to learn about GNU Radio 4.0, or to, it's not just going to be about GNU Radio 4.0, so in the GNU Radio 3 world, I will do a lot of stuff that I wanted to tackle for a long time. You're very much invited to Lyon. What we can't really offer, it's not a conference, right? We don't have a track with talks that address a wide range of people. It's something where people sit together, have a presentation, and then hack on something that they wanted to. So you need to bring your own motivation to do something, maybe. But yeah, so mid-next month, please do consider going to Lyon and show up in the GNU Radio chat. This is something that after going off script for so long, I've got on my piece of paper here. Do really feel encouraged to show up to the GNU Radio chat. It's on gnuradio.org. You find how you can contact us. Yeah, use the software. And please, if you are interested in that book, check it out. The table of content is online. A lot of things about the book are available online. If you have any questions, we are right there. And if you have any question, is exactly how I'm closing this part of the presentation, and I would like to open the stage now for questions from the audience. Thank you very much.
Thank you very much, Markus, Javier, and Michel. Hello. Any questions or comments from the audience? You haven't read the book? You haven't learned what all these formulas and equations are expressing? You do not remember now? Oh, I see bad time for the end of the semester.
Okay, here's the question.
Okay.
Yes, does the book also address latency dependencies? That something that you cannot implement in software-defined radio just because of the latency between the ADCs, the processing?
In all our examples, we have no closed loop. So it's neither hardware in the loop nor closed loop. It's always open loop. So in our case, latency is just a delay in the stream. So we do discuss how you could steer a clock. For example, when you're receiving GNSS signals, you get time information, and this time information can steer the clock, time tagging each and every sample. And under the assumption that the stream is continuous, you can implicitly time tag each sample. But we do not have closed loop system where latencies would be reducing the closed loop bandwidth.
Yeah, and as mentioned, these are one of the hard problems. And actually, like all of the topics that we proposed for that meeting in Lyon, there's one how to bound the latency through processing within a GNU Radio flow graph, which has been and still is a big issue because it's very buffer based. So feel invited.
More questions? I have a question.
Yeah.
So what is actually I've never tried it out. Maybe I should try it out, but what is actually the maximum sample speed you can process with GNU Radio?
So on this laptop, no, it actually,
Where are the limitations?
Mostly memory bandwidth. So if you get your samples in and can obviously if I process something with a 10,000 tap filter, then that takes a lot of time, and GNU Radio itself is not like the GNU Radio 3 version is not perfectly equipped to do something like inherently take that filter and distribute it across multiple cores. You need to know what you're doing and then do that, choose an implementation that does that. But we do see by now 100, 200 mega samples per second flow graphs being implemented in software, and that's foreseeably where the GNU Radio 3 world will be stuck due to architecture in the end. The GNU Radio 4 world, I don't actually know what will be realistic on current hardware. We see speed ups between 10 and 100 times for specific payloads with identical computation, which is mostly because GNU Radio 4 is able to make use of CPU caches, whereas GNU Radio 3 kind of is doing the worst thing for that by making the architecture a bit easier to understand. As a bit of a background, the GNU Radio 4 development is mostly sponsored and led by GSI-FAIR, which are operating particle accelerators, like large rings that bring ions to near speed of light and collide them and then get some measurements out of them. And they get a lot of measurements per second and a lot of channels of measurements per second. So they needed something to write, and they contacted Upverse graciously and said, hey, can we maybe take this GNU Radio that we're already using and improve it for reliability, for industrial scale application, for usage in large-scale research facilities, and still have it be a community project that benefits from, yes, someone implemented a QPSK transmitter because they wanted that. That's not something that you very commonly need in heavy ion research, right? So, and they will probably correctly tell you, like, this depends on how large your server rack is, because they can then say, okay, for problems that are possible to multi-thread, that's much easier in Radio 4 to say, I have a function that takes 1 sample or 100 samples, and I can replicate that function and just do it in parallel. We do have things where the actual computation is done in Radio 3 on the FPGA of your SDR device or on a GPU. We put special work into these computational domains so that your CPU never has to touch your samples coming from your front end just to do, say, an FFT and the decimation on it, which is a very common problem. But it, of course, then still requires you to have either prepared blocks that you get from someone or write them yourself for these target domains. So this is still an open problem. And the question, how fast can we go, is a really interesting one, because I showed the radar example, and radar works best, like radar resolution scales with bandwidth, right? So I can have a toy radar with GNU Radio, right? And I can have a really interesting radar with the 40 megahertz that we saw on the ESP32 talk earlier today. But if I want to have something that can tell me how close, say, the car in front of me is, I might want to have higher bandwidth, right? So this is a very interesting problem, and we're really optimizing that. And that's really also one of the reasons why we're taking these big risks, right? Where we say, okay, we're taking this, I think we're 20-ish now, year-old software project in Radio, and we're cooperating with someone who rewrites that, right? That's a huge problem because you lose so much, right? You have to put an extra effort to pull out every single block that you've ever written and make it available in a new thing. And so that's why we're doing it, because in the current architecture, certain things are just not gonna happen. We're not gonna be the tool of choice for high bandwidth things, right? That's. Thank you for that question, honestly.
Yeah, because we have another speaker later here, which is Thomas Bögel, and I've asked him if he could give us an overview about a modern analog digital converters, and also regarding the speed, the maximum performance, where the industry stands, what kind of devices we have, and they produce an awful amount of data.
Yeah.
And the question is how far we go there and how to speed up things. So yeah, this is probably a very important field of research. We have another question from the audience. Please go ahead.
What are the prerequisites to make best use of the book? I mean, do you need a degree in electrical engineering in a lab, or is it sufficient to have some basic compute and I don't know, what knowledge do you need to actually benefit most?
Well, I think we start really from the beginning, playing with signals. Concerning the computer science side, it's like using a software with blocks. If I speak about the GNU Radio Companion, which is the software that allows you to build the different flow graphs. If you know how a communication system works with the different elements, functions you've got in a digital communication system, you know about filters and things like that, I suppose that can be, well, the book will really benefit to you. We forgot to mention that all the flow graphs we've done for the book are already, you don't have to buy the book. They are available on a GitHub, and it's open, so you can already have a look on this flow graph. Another thing I wanted to mention also to check about your level in this field. There's also the GNU Radio Wiki, which is absolutely excellent, because there are several persons working on that, and over the years it's getting better and better, and it's really well done. So go and have a look on this wiki.
All right, so we've exceeded the time limit a little. Nevertheless, thank you very much, all three of you. Thanks for coming here. Thanks for being on the screen. And Jean-Michel and Hervé, and I hope you'll be here next year.
Yeah.
Yeah. Thanks for the invitation. Yeah, I'll think about it.
Okay, thank you very much.